Hi, be ready to understand the concept of eigenvalues just under 5 minutes. Let's go! So the three questions that I am going to deal with are: what the hell are eigenvalues? Why do we even care about them? And who was Eigen? Now who was Eigen? Although there was a person named Manfred Eigen, a Nobel Prize winner German biophysical chemist, but sadly he is not responsible in any manner for eigenvalues. In fact, eigenvalues are not named after any individual, but Eigen is a German word meaning own, which is a good way to think of values that are characteristic of a matrix. And as you may have expected by now, this term was also coined by a German mathematician, David Hilbert. ये Germans भी लगता है Eigen word से बहुत ज़्यादा possessed थे. Now, why do we even care about them? Because they are used in a wide range of applied works, be it stability analysis, vibration analysis, atomic orbitals, or even facial recognition. So the people at Apple seem to be exploiting the powers of eigenvalues in their latest release, iPhone X. Surprisingly, all music is just eigenvalues and eigenvectors. The strings of a guitar, a sitar, or a santoor, they resonate at their eigenvalue frequencies. So that means you have been listening to these eigenvalues and even dancing to them since a long time. That's terrifying. In fact, the search giant Google uses eigenvectors and eigenvalues to assign page rank to pages and rank them on Google search. That's also awesome. Now what the hell are eigenvalues? If you will search it on Wikipedia, you will find that it explains it as: in linear algebra, an eigenvector or characteristic vector of a linear transformation is a non-zero vector that changes by only a scalar vector when that linear transform blah 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 blah. Are you also feeling like this? Well, don't worry. I have a simple definition for you. Now, an eigenvalue is a spatial scalar associated with a square matrix that satisfies the following relation: A times a vector x is equal to lambda times vector x. Now what does these quantities stand for? A is a square matrix of some order, say n by n, because it is a square matrix. It has to have equal rows and equal columns, so say it is a n by n matrix. Lambda is our eigenvalue associated with A, and x is our eigenvector associated with the eigenvalue. Now this definition leads us to another definition that is very useful in calculating the value of lambda associated with our square matrix. Now what is that? It is that the determinant of A minus lambda I has to be 0. Here I is the identity matrix of the same order as A. 0 is the constant 0. It is not a vector, not a zero vector, but it is a constant 0, number 0, and the bars on the left and right are used to denote the determinant. Now, what is the relation between the two definitions? You must be wondering how this definition that is used for the calculation purposes arrives from the first definition that we looked at. The first definition was A times x is equal to lambda x. Now, how did we get to this definition involving determinants from this first definition? Don't worry, we will see that. From the first equation we have A times x minus lambda times x must be 0. Here 0 is a null matrix, not a constant, because we are not dealing with determinants, we are dealing with matrices and vectors, so it has to be a null matrix. So how did we derive this? We just shifted lambda x to the left. Rearranging this equation, that is taking x outside, what do we get? Factorizing this equation, we get A minus lambda I whole times x is equal to 0, because lambda x can be written as lambda times ix, the law of identity, right? Obviously this equation would be true if either A minus lambda is 0 or x is equal to 0, but these are not going to be very helpful since these are just the trivial solution. So what should we do? Thus, in order to solve a general matrix equation like we have Bx is equal to C, we would normally find the inverse of B to get x is equal to B inverse times C. Using this technique of solving the given matrix equation, we would get x is equal to A minus lambda I the whole inverse times 0, which implies x is equal to 0. However, again, we are looking for a non-trivial solution, so we must prevent this from happening. The only thing that would stop us getting x is equal to 0 would be if a minus lambda I does not have an inverse, or in other words, if a minus lambda I is a singular matrix, which is to say that determinant of a minus lambda I is 0 into the product. Therefore, in summary, an eigenvalue is a scalar value, a constant value that helps us to transform a square matrix into a vector form with the help of the associated eigenvector. You must be wondering what the eigenvector is, how do we really calculate eigenvalues in practice, and so on. I know you must be having many more questions. In order to address them properly, I will be making more videos soon. So if you have enjoyed watching the video, which I hope you must have, then please don't forget to subscribe to my channel and hit the bell icon so that you get notified whenever I upload a new video. Thank you for watching.